like imbibing alcoholic beverages, please use the bar upstairs. The money comes to us, and then we can put it back into the night's festivities. If you go downstairs, we don't see any of that. So help us to help you and buy the liquor upstairs. Let's see, there's, for those who have received the red raffle tickets, and Bon has a couple of them as well to give out at his discretion. For those who have received them, you can turn them in for prizes at the registration desk.
Your mic didn't anything, right?
Yeah.
I believe ad hoc already, for those who don't call it clear, ad hoc also has a competition where if you bring Dr. Pepper, you can offer a hug. I believe he has some tickets. If he ran out of tickets and you do this, I'm sure he will still enjoy it. So feel free. Let's get we'll get the talk started by Bon Welch. I know him well. He's a colleague of mine, well, former colleague now from IU, and he's going to talk to you about open assurance market or software assurance marketplaces. Really cool stuff. Enjoy.
All right. Thank you. Good morning, all. So a little bit about myself. I come from the scientific computing community. So I've basically grown up working with scientists around the world who use computing either for simulation, data analysis, whatnot to do their computing. And first I was helping them with their high-performance networking needs, and then somewhere around the mid-90s when we all realized, hey, we need cybersecurity, I got plugged into the cybersecurity position. Now I've got the good fortune of working down at Indiana University in Bloomington, where I'm a deputy director for the Center for Applied Cybersecurity Research, which means I get to deal a lot with federal funding agencies to find money to fund our work. But really, I run a team of sort of white hats who try to make cybersecurity, if you go back to, for those of you who are here for Dave's talk, and we're blue team, trying to make the lives of the blue team easier and figure out what it is we're really doing in cybersecurity, how we manage the risks, and so forth. And we do a lot of work all the way from policy and legal side and helping craft legislation and policy on that front to the very technical side. So I'm going to talk about one particular project we're involved with today, which is something called the SWAMP, or the Software Assurance Marketplace. So out of curiosity, do we have anyone here who develops software regularly? A couple folks. Do any of you ever do any assurance testing on the software developed? Either static code tools like Coverity, or you stand it up and use dynamic tools in testing? A couple little bit. So what I'm going to talk about here today with the SWAMP is going to be a little bit of a mixture of two things. We've got actual infrastructure that's up and running and today, and we also have a longer-term vision, which is guiding that infrastructure. So what I'm going to show you today is, the infrastructure is a work in progress. It's working today, and then we've got a vision on where it's going. And really why I'm up here is I want to hear feedback. We've got something today. We know where we think we're going. Are we going in the right direction? Are we missing obvious things? What would it be to make it more useful to you? And as I'll talk a little bit about, this is more than just people who are software developers. We all use software. How do we get any assurance about the software that we use? So, and by the way, I'll mention Mark down here. Mark Krenz is my lead security engineer on this project. Susan Sons down here is also part of my team down at IU. So, going a little bit back, just a little bit of background, and for those of you who are in the room for the previous talk, you've heard this, nothing has changed. Back in '88, for those of us around for the first big internet meltdown caused by the Morris worm, was just a buffer overflow attack. It was software that didn't check the length, copied more over, and the worm was able to propagate and literally shut down large chunks of the internet back then. That wasn't very hard back then. We were dealing with connections back then that are smaller than most of you probably have from your ISP between major universities. Then, part of our team, Bart Miller, who's a professor up at University of Wisconsin, good colleague of mine, introduced random fuzz testing. And for those of you who haven't heard about fuzz testing, it's real simple. Take a piece of software, you start running it, throw random data at it. If it crashes, hey, you've got a place to look for your first exploit on all this. So he pioneered this back in '89 and started figuring out all the different ways you could formulate it. Sometimes you do semi-structured, sometimes it is purely random. Sometimes you put angle brackets around it, and hey, it works a lot. It's a lot more efficient. And so we had all this. And, if you look at the CWEs from SANS for this year, we still have these same problems today. So these bad software problems have been around forever. They continue to be around. Plus, we have a whole litany of other things, which I'm sure you're hearing plenty about here at this conference, to worry about in addition to these. So this problem with software is getting worse, not better. So what do we need to do? It's sort of easy to sort of sit there and go, well, why can't these software developers just generate better software, right? It's easy to sort of shovel the problem off onto them. But, if we take a step back, we need to figure out what it is we need to do to help them. And it starts with education. We've got to educate them on the issues. We've got to educate the management as to why it's important. So they have security in mind, and they've got some understanding of how to go about that. We need to give them the right tools. And today there are some good quality commercial tools out there. The open source ones really are pretty lousy if you try to use them, particularly the static code analysis tools. If you're trying to test your code, you're in for quite a bit of effort. And so one of the things we want to do with the swamp is to start tackling these issues, starting with the ease of use of running some of these tools, but really with the vision is getting all the way up and down this set of problems. One really common thing you run into today is you take any piece of software, if you're a developer, hey, you've suddenly seen the light on security, you go grab yourself Coverity or any good analysis tool, you run it, you end up with a list of problems on, as long as your arm, then down the other arm, then probably down at both your legs, and you go, oh crap. Well, that was depressing, and you file that list away somewhere, and you now go and get your next feature cranked to get out the door so you can get done. And so part of what we have to do here is, once you've sort of gotten to the point where you've got a large code base, and now you're trying to go back and deal with software issues, you're in a world of hurt. So one of the right things we recognize is we want to get at the software development early, because the earlier you get at it, the better you are. And the concept we want to push on this is, today we're starting to see, you get things like Jenkins and so forth, sort of continuous integration testing. You get to the point where every time you do a commit, you can have that commit tested, you can have it verified, and make sure you didn't break any functionality. Well, what we would like to do is push that to the point where, hey, not only you make sure you didn't break any functionality, but get the assurance testing on that to make sure you didn't introduce a new bug. So you're at least not getting things worse. And if you can get this done as early in the life cycle as possible, you now have the ability to start building the code up from the beginning. So a little bit more, some basics about what the swamp is. We're a grant from the Department of Homeland Security, and I'll talk a little bit more about that government connection later. We're from the Science and Technology Directorate in DHS. And for those of you who have dealt with most of DHS, it's a big bureaucratic organization. The S&T Directorate is the one part of it, I think, that really funds good quality research and development. So this is, a lot of DHS tends to be interested in incident response, getting gas masks out and so forth, which is all good work. This is one part of it that really is forward-looking. And what we're doing here is we're building a facility where open source software can be tested for vulnerabilities for free. The goal here is really to get better software out there for the whole community. The government's very interested in open source software now. It wants open source software to be higher quality. And what that is, so on the ground, we want to allow for better testing. Ultimately, we want to get software researchers a place where they can actually improve the software assurance research out there so we can get better tools. We've got a team. These are my colleagues up here. I'm the one down in the lower right. I don't know if you can see it in this lighting. The other three are smiling. I'm the chief security officer, so I'm not smiling. So it's my job to try to keep all this safe while we're doing it. So we've got some vision here, and there's a whole white paper on this you want to read, but I think the interesting points down here, which I've gone over a little bit, is this set of abilities to identify defects, to identify new ways that tools can be improved, to identify both how software has weaknesses, how tools have weaknesses, and this is where sort of the marketplace concept comes in. And that's sort of a strange word when you think of a software assurance, but the idea is it's a place where different software people, different software tool providers, different researchers can come together and not only compare tools to one another, software to one another, but also share experiences. And so this is, the idea is it's an environment where we've taken a lot of, the buzzword today was taking a lot of the friction out of the process. And so for those of you who have tried to use these software assurance tools, there's usually a good deal of setup involved. They've got to figure out how your software builds, what source code is really relevant, what source code is not relevant, what the heck do all these warnings mean, which ones of them are false positives, you're going to be drowning in false positives. And so what we want to do is bring these tools and the software into the environment in such a way that we take care of a lot of that grunt work for you. And that sounds, in some sense, it's an engineering process. But when you're talking about a software developer who's under pressure to meet deadlines, making things easy and quick is really important to get yourself integrated into their workflow. And so there's a list of high-level features here of the swamp. And what you're going to see the word easy up here a lot. And you're going to see support for multiple tools. So we're not developing software assurance tools. We're like those, for those of you who remember these BASF ads, the idea is we're trying to provide the right framework to make all these things better by giving people a place where they can easily and quickly try them against things. So I'm getting a little bit more concrete here now. What the swamp offers is the automation process. So it's the place where you can run tools easily. And the idea is that you can take a tool, take a piece of software that have never been run against each other before, but allow that to run with very little effort. And some of that is just working out all this sort of glue between what a tool expects, what a piece of software expects. We spend a fair amount of time bringing a tool in, making sure we understand it, maybe standardizing some of its output so that it looks the same as other tools. So when you run two tools, you can understand the difference. Figuring out how you run it, going through all that sort of read the manual stuff, and trying to automate as much of that for the user base. And then the idea is once the tools start running easily, and you get feedback from each one very quickly, then we start making that a process that somebody doesn't mind doing frequently and often. And hence we start moving towards that continuous assurance. And then, getting a little bit now, I'm going to be clear here, we're moving past what you will actually see today and a little bit more into the vision, is the ability to start automatically combining results from different tools. So maybe we figure out one tool is really good at buffer overflows, another tool is really good at SQL. Wouldn't it be nice to get the best of one tool and best of the other tool without having to wait around until somebody figures out how to write these two tools into one? So the idea is we can get the results and pull them together. We've got some smart viewers in there right now. We've got our own simple viewer. For those who are familiar with the Code DX project, we have that tool is integrated with the swamp, and you can use that in addition right now. And the last bullet on here is a key one we really want to work for, is the ability to track progress over time. So you can see if you're getting better, if you're getting worse. So if you figure out that something's a false positive, you can flag it, and it goes away, and you never get bothered by it again. And so you can start filtering down that long laundry list that's running up and down one side of your body. Novice and the expert, and this is a key thing that we really want to push for, and we understand, kind of like the survey I did, we've got a few people in this room who are used to software assurance tools, and being able to give them the power that they need to do some of these things. It's that old, you want it to run real simple, but then you want to be able to crack open the control panel and do the complicated things first, if you need to. Another list of attributes. I'm going to talk more about the security and the privacy here in the moment. The openness refers to the fact that people can bring their own tools and bring their own applications into it. We have some there that you can test against. It's a resource. We've got the computational power to run things in the hard disk space, and that's located up at our colleagues up in Madison, Wisconsin. And then the automation. So what we've done is put a lot of effort into the being able to automate all this and bring it in. So what's real today is an assistant with 5 static analysis tools sitting there that have coverage on C, C++, and Java. We've got viewers that let you view the results, and plumbing that handles all the ugly stuff, all the sausage making to actually get to those results. We also have software packages in there. And as a software developer, you probably don't care about that. But if you're a tool developer, if you're someone who's trying to develop a software assurance tool, that's what you care a lot about, those packages. Because what we give you is a way of bringing a new tool that you're developing in and running it against those 100 packages and being able to see how you do under different situations. And some of these packages have well-known defects in them. So you can see if you can catch things or not that are meaningful to you, or if there's things that you're missing. And we've got the big iron and so forth, and I'm not going to go into the numbers there. You can read them if you want. So let me jump here to sort of the cartoon architecture. So I think it might be a little bit easier to understand for that. At the core of what we do is perform what we call an assessment, which is very simply taking a tool, applying it to a software package on a particular platform, which it turns out matters a lot because different software performs differently depending upon what libraries you link it against and how the different libraries behave. And then that gets you a set of results. And those results can be viewed raw, and that's sometimes if you want to do that. Most often not, you want to have them parsed down and simplified. You want to filter out things that are unlikely or obvious false positives. And then you want to get down to a set of parsed results that you can look at. And so this is sort of the very high-level workflow of what it is that we want to do. Now, let's talk a little bit about key communities that we think really need this. I've talked a lot about software developers, and that's obviously a really important user group on the ground because they're the ones that are actually creating software. I've mentioned a little bit about software assurance tool developers and software assurance researchers who are trying to make our ability to automatically detect weaknesses in software better, to get rid of the false positives, make it more likely that when we found something, it's really a problem. And we spent a lot of time poring over Heartbleed and these other bugs. Why weren't those found by conventional tools? And they weren't. And the reason is modern software is very complicated. And so these tool developers are advancing their craft. Part of what we're also considering is maybe we need to be writing software better so that it isn't so complicated and make things hard to find. So there's some work really going on in that space. So part of what these folks may be doing is saying, hey, if we wrote the software differently, does that make it easier to find the bugs in it? We're also looking at educators and students. I mentioned education's key to this. And one of the places where we're seeing adoption is in software engineering courses in schools. And you can have students, this way they can go off, you can have them go do a coding assignment. They get done writing their code. You can upload it to the Swamp, and the Swamp can spit back at them, hey, here's a bunch of things you did that look pretty iffy. So they can get that immediate feedback from a facility that says, you maybe need to work on this right. And you can start building this software assurance into a software engineering course and having students learn it by integrating it into the sort of the automated process they might have for submitting their assignments already. And finally, we have infrastructure operators, and a couple different names around this. Sometimes it's called supply chain in some circles or somewhere, but I go back to a use case. I'm running a computing facility. Someone wants to bring in the newest version of some open source application and run it server. Great, what do I know about this? Well, unless I want to spend probably weeks pouring through source code, and weeks is probably optimistic there. I mean, people are spending months right now auditing OpenSSL. I'm really just taking a leap of faith running a piece of software in my infrastructure. And this is a real decision that happens every day in critical infrastructure, computing facilities, and whatnot. And so part of what we really see as our key customers is the ability of someone who's got a piece of software they know nothing about, somebody wants to run on their system, they want to give it to us and get back. We're not probably, unless it happens to be the luckiest piece of software on the planet, we're not going to tell them, yeah, this software looks great, but we want to give them some idea of what their risk is. Not running any piece of software you haven't written is going to be a risk, even software you have written. But give them some sort of quantitative idea of saying, yeah, this looks more riskier than not, or this looks, safer than some, and give them some idea. Talk a little bit in more depth about that. If you're a software developer, obviously your key goal is software and quality of your code. You want to do it. We would like, get to the point where you can do it easily and often, and that you can have the software integrated into your development practices and make it part of the routine workflow, instead of today where it's an afterthought that's done right before it's shipped or when somebody comes in later and wants to audit it. And so this is where a set of capabilities largely around automation and around improving the viewing of the results, right? So instead of this long laundry list, you get something that's a little bit more intelligible, prioritized, ordered, and filtered around that. Key thing that we see is privacy here. And one of the things that's always a challenge in this space when you're trying to help somebody improve their security is fear of embarrassment. And I've seen this over and over again. Nobody wants to bring a piece of software in and then have it published that, oh my gosh, we found 56,329 weaknesses in your piece of software. First person who does that, the second person's not going to come to that. So the results on this are private. If you do that, you own the results. We're not going to tell anybody about it. We're not going to publish numbers on what you want to do. If you want to take it, run off and throw it up on your website, that's your business. We're not going to do it. That choice really lives with you. And we see that as something as critical as to building up the trust of our community, is them feeling confident that when they bring things to us, we're kind of like a good email server. Your email might go through us, but we're not going to share it with anybody. You may do your software assurance with us, but we're not going to share it with anybody. We're providing the infrastructure on that. So the ultimate goal, so moving on, tool developers' goals is they want to improve the quality of their tools. So if you're developing an open source tool that does software assurance, or down the road, we hope to support commercial providers. And what they want to do is they want to find more weaknesses. So in other words, they want to find more true positives. And really, really importantly for these software assurance tools is they want to reduce the false positives. And this is a real killer today because with complexity of code, it's really hard to tell. And so today, this balance right there is really a huge challenge for the industry. And what we want to see is have a better feedback loop, is to let them improve that balance and that trade-off more quickly and hence make it better. We want to get actually more software assurance tool developers out there. I'm always impressed. I think the quality and number of tools for hacking far exceeds the quality and number of tools for testing software and making it more secure. Part of that, I suspect, is the former might be a little bit more fun. Part of it is, I think, the latter's a little harder. And so what we're trying to do is just lower that bar for people to get into that game and develop better software assurance tools. And then finally, we want to provide a showcase for a tool. So we'll provide a place where, hey, if you get a good tool and you think it's good, you can come to us, say, hey, I'd like to let any other user of the swamp use this, and we'll provide a mechanism to do that so that you can have a place where the community can use it without having to go find it, download, install it, figure out how to run it, et cetera, et cetera. So a number of the same capabilities here, but just sort of pivoted around to look at it from the tool developer's point of view. But really, they want a lot of the same capabilities to be able to automate their tests, make them as easy as possible, view and compare their results. They're probably going to want differently. So instead of against earlier versions of their software, how do they compare earlier versions of their tool? How do they compare with other tools that are out there in public? How do they compare against these synthetic test cases? Software that has deliberately had weaknesses put in it. Are they catching those weaknesses? How much stuff in those software are they not catching? Et cetera, et cetera. So tool providers, I think I chatted enough about this. You want to, it's more the E stuff. A little bit of talk about what we need from tool providers to automate the application of their tools. And what we really are trying to do, and we've done successfully so far, is not require modifications of tools. We want to be able to bring tools with us. Is that a question? Today we are doing static analysis. I'll talk, there's a little bit in the vision on that. We've got some things in place to do binary and dynamic analysis down the road, but everything's static today. So we want to make this as easy for the tool developers as possible. So we don't want to require them to modify their tool. What we do want to do is, we do need to get information from both the package and the tool developers on how they're supposed to be run, how to tweak the warnings, and work with us to minimize the number of the false positives, minimize the warnings, and so forth, and work through that issue. So there is some back and forth with the tool developers. And we find we do have to do a lot of tuning of the tools to sort of try to hit their sweet spot for a generic run, because most of the software developers don't want to spend a lot of time tuning the tools. So what we want to do is work with the tool developers to hit a nice spot with their tools so that if you run it by default, it seems to hit that nice balance between false positives and true positives. The software researcher's goal, or the software assurance researcher's goal, is a little bit different. And we've talked to a number of folks who study some interesting things like what makes a software developer more likely to use a software assurance tool. Is it ease of use? Is it the type of feedback? And people who have actually sat down and watched software developers develop and tried to understand what makes it more important. How important is the role of management in software assurance? If the manager says do this, are you going to do it, or are you just going to run through the motions? How long can that laundry list be before you just give up on it? How short does it have to be? Are we, if we only find the top 3 bugs and print out 5, if we print out 5 things and 3 of them are real, is a software developer more likely to deal with that than if you print out 100 where 80 of them are real, right? These sorts of balance that sort of get into human factors and natures. And they really want to sort of study the process. And so these folks were here, and so we want to give them the ability to come in. And this is where we start thinking about things like anonymized usage results and so forth. And I'll talk a little bit more about that later, because obviously we balance that with privacy. And this is the some statistical analysis and so forth for them. So let me shift to the educators. And we talked a little bit about them. And so this is educators who are both educating software developers. They may also be educating security analysts, and they may be educating developers of the software assurance tools. And so up and down that set of different use cases that educators may have. And so our goal with them is to really allow them to become a user of the swamp easily. There tends to have short-lived projects, maybe a week or 2 during a longer course on software engineering. They're going to have a bunch of students. And this gets into one of the challenges of running an open facility like this. We have potentially lots of users who are coming and going. And this is one of the fun parts about being a chief security officer is I don't know who my users are going to be from month to month, even week to week at times. And so this is all fun. And so students really do need things easy and streamlined well. And so you want to bring them in, allow them to be added in large groups. You want to isolate them from one another, and you need the instructor's sort of ability to manage their progress, right? So this is sort of an interesting use case from our perspective, but it's really critical for an instructor to come in and be able to have 30 students who are progressing through this, and that instructor gets some idea of how that goes. But the benefits are pretty strong on this. Having the real world experience, particularly as students, is really critical. I mean, you can sort of talk about software security a lot in the abstract with them, but there's nothing quite like having them be able to sit down and having something point out the weaknesses to them in their code. So being able to take something that right now is a manual process for an instructor and turn it into an automated process where it can be part of just a normal code check-in is a really powerful time saver for the instructor. It's more likely to get it going. And so this is one of the reasons why we're really excited about this in terms of the long-term benefits. And so, we really want to push on this, at the undergraduate level to learn more about the continuous assurance, and then we start thinking about it at the graduate level as it being a resource for learning really about the details of software assurance. And you've got students there who may be developing their own software assurance tools and can bring those in. And then also they can do testing on some of the more intricacies of software engineering and see whether or not perhaps different engineering practices, you get to Agile versus Waterfall or something like that, if those make a bigger difference in how secure the resulting software is. So the last use case is that infrastructure operator one that I mentioned before. And it's that very tricky one because, not only they're not a software developer, they didn't write this particular piece of code, and they're just looking for some notion of how secure this code is. And it's a tricky use case because, now we have people who may be wanting to run assurance on software that they're not developing. And so this is pushes us in different directions. One of the early thoughts that we have is, well, you want people doing this on software that, they're going to turn around and use the results for good and not for bad. And the first thought you have is, well, we'll limit it to the people who are actually developing the software. But then you realize that most of the people who care about the security of the software are users of the software out there. And the developers may or may not be interested in it. And the developers may not even be around anymore. One of the advantages of open source is it can live on even after the developers have all drifted off to other things. And so having this ability to support third parties, being able to do assurance testing on software. So segueing a little bit into talking some about the security and confidentiality, which is the world I'm most concerned about. There's a number of balancing acts that have to go on here. And these tend to be some examples of, real world blue team, white hat security as you do this for real infrastructure. We want to have easy access to this. Our goal is to foster more software security. And like any technology here, we're providing a tool that can be used either for good or for evil. And so we really want this balance of easy access for the software development, the software tools community, but we want to dissuade illegitimate use. And having run open computing facilities for a couple decades, you really find yourself in a trust but verify mode on this. There's no way, you can possibly track down whether or not someone wanting to run software assurance on a piece of open source software that you've never heard of, is really the legitimate owner of that software or really intends to do that. But what we can do is monitor and make sure that, if someone's running against a piece of software, we're not suddenly seeing exploits appear for that, or they're not doing something that just seems obviously fishy on that front. We're going to have, as I mentioned, educational users, students who may be on for a week or two versus, folks who do software development projects for years. We're doing mostly open source today. Eventually, we want to support commercial tools, which gets us onto all sorts of licensing and intellectual property issues among who can have access to those tools, and making sure that you can use a tool, for example, but not actually make a copy of the tool and ship it off. So different challenges there. Today, we offer web access, and I'll give you a quick tour here in a moment. But we know API access is really critical in integrating with IDEs and other development environments in such a way as to be seamless for the software developers using it. Mobile applications are something that are on our radar down the road. Today we're looking at primary classic OSs, but doing the mobile applications we know is something that's going to be important. And we're also balancing being a very neutral shop that lets you do these runs and do these assessments versus offering guidance and ranking. It's very tempting for folks to want us to turn us into a clearinghouse where we can say, well, here are these, this piece of software got a 7, this piece of software got a 9. But the reality is that, application of the software tends to matter a lot. And if you're putting it into a piece of critical infrastructure your tolerance for risk may be a lot lower, or your need for the software may just be a lot higher. And you may have different scenarios where if you're putting it into a website that's open to all the internet, you may be much more concerned about a certain class of vulnerabilities than if it's buried deep in a library stack on that same system. And so we have to sort of balance those sorts of things in terms of giving guidance. So this being a little bit of a hacking security conference, I just want to talk a little bit here about the sharing confidentiality and privacy issues. And as I mentioned before, we're DHS funded, and that puts us in kind of a bit of an odd situation right now. I'm guessing everyone here has heard of the NSA and issues around that. And one of the questions we have is, well, if we use the swamp, are we giving DHS access to everything we have? And the answer to that is no. So we're funded by DHS, and I live most of my life getting funding from various federal government agencies, but we're not part of the DHS. I'll make that clear. So we're universities. I'm at Indiana University. My colleagues are at Wisconsin-Madison. And part of this is we have an agreement in writing from DHS that says, look, people who put things into the swamp, they own it, it's theirs. They're not going to come asking for it. We're going to give reports on how often it's used, how many users we have. We're going to anonymize all that, and we're going to make it public. So this is one of the things where we're really working to make sure that we have that right blend of transparency so people look, here's what we're doing, here's the rights you have, and here's what we're not going to do with your stuff. So this has been a key point to us to really work through. I have to say the timing on this has been lousy to be a federally funded project, but we're working the best we can to make sure that we've got the right walls in place, because the ultimate motivation here is to make software everywhere more secure and to give us all good privacy and security protections. So we want to really work through that, and to be quite honest, if there are things that people suggest we can do on that front, I'm all ears on that. Yeah.
Keeping a tool developer with a bit of extra code to make sure he gets a copy of everything.
So 2 answers to that. I mean, first of all, we clearly make that through our policies say you can't do that. Right. Second of all, tools are going to be a little bit easier because at least right now there's fewer of them, and so we can have monitoring for that sort of thing. Honestly, we can't, I can't sit up here and make a claim and say it's 100% impossible not to do that, but I will say it's going to be very difficult for someone to do that for any period of time and not get caught. So, no, that's the sort of thing. I mean, it's one of the challenges here is we have so many different stakeholders in a marketplace and balancing the needs of all of those. Mark and I have spent a lot of time sitting there with big risk and threat table models going, well, what if this person does this to this person, and they turn around and do that to this person? So, yeah, we've thought about that, and we've tried to make sure that we make it clear that's not allowed. We try to prevent it, and then we also try to detect it. So the second point up here, just to make that explicitly clear, any software you put into the swamp is owned by you. We don't take any rights in it. We don't make any claims of it. We're not going to turn around and do anything with it that you don't explicitly give us permissions to. Now the third bullet says, though, however, we do give you the option to share. And I think I've got another slide on here to talk about that. We've got a couple forms. You can be public. You can be also sort of limited sharing. And I'll talk about that in a second. And this all builds down to that fourth bullet, which is the strong trust. And we need that. So I really welcome feedback on any of this in terms of security, because we don't want this to, our goal is to develop better security for the whole software ecosystem. So whatever we need to do to build up community trust is obviously paramount on that. We've got a privacy policy, which I won't go into detail, that codifies all this. It's just a matter of good practice. Here are some of the sharing I talked about. Privacy is obviously default. You put something into the swamp, only you have access to it. At the bottom is public, and what public really means here, it's a little bit of a misnomer, means anyone else in the swamp has access to it. Then in the middle is really sort of the interesting case, we call it protected. We have this notion for classrooms or for teams of having projects set up, and you can share things with the project. So you can put a software up there and give access to a project, and put a tool up and give access to a project. Your results can give access to a project, so different members of the team can look on this. And also, frankly, so if one developer leaves, you don't all of a sudden lose access to all that state. And users modify their sharing policies at any time. You control them. You can share, you can unshare, et cetera, et cetera. We spent a fair amount of time working on an architecture for the swamp to really try to control privacy and security. And these boxes up here, this is another architecture cartoon, as I like to call them. But these boxes are significant in that they delimit where different information can go in the swamp. So we've spent a good deal of time saying this sorts of information, when you log into the swamp, you provide us your email address and other sort of personal information. Well, that can only live in one particular part of the swamp. Results can only live in another particular part of the swamp. And so we've done this both so that, we can help detect if we have a problem. If we see information that's in a part of the swamp it shouldn't be, we immediately know we've got something wrong. But also then this really simplifies when we start doing things like detection and prevention, where we have to look for issues being leaked. Swamp security, I really liked, for those of you who were in the room in the previous talk, Dave talked about purple teaming, which was an interesting combination of both defensive and offensive. And what we have in place in the swamp right now, which I think that kind of resonated with me, is a shared responsibility. So as I've mentioned, the swamp actually sits up in University of Wisconsin on Madison, and there's a systems team up there that handles the day-to-day implementation of the infrastructure and a lot of the low-level security details. Then my role here, and working with Mark, is we not only work to set policy, but also act as sort of an ongoing, red team may be a little bit strong, but ongoing audit team. So we're constantly checking up on them and making sure that they're doing the right thing, aren't slipping up, aren't having faults. And so we have a little bit of that. I'd never heard it called a purple team before, but have a little bit of that constant feedback infrastructure going on. And so this is the first time I've really been in that sort of arrangement where we've had the security team really split across two different organizations like that. But I have to say, so far, I really like it in terms of having that constant checking up going on. And then additionally, on top of that, another colleague I haven't mentioned, he was one of the smiling faces back on that one slide, is over at Illinois, the National Center for Supercomputing Applications, Jim Basney, who's done a lot of work in identity management. And so he's sitting there also double checking all of what we're doing for authentication and two-factor work and checking up on those, and also acting as a sort of a security quality assurance person in his own right. So looking at making sure we're not doing a lot of the common problems with web authentication, cookie goofs, and so forth. So it's worked out well to have the multiple projects involved from a security perspective, I think, because it's the different groups checking up on each other. On the right here, I've got some of the usual marketing talk. I would say, we've done a lot of good practices on that. We've had an outside pen tester come in and do things on that. Frankly, I wasn't terribly impressed, so I'm really glad we do our internal testing. And then finally, we eat our own dog food in terms of doing software assurance on the code that we're developing for the swamp itself. And so we spent a good deal of time setting up a plan on that and going through the software process. And right now, we don't have the tooling to actually test. We're mostly a PHP shop for the swamp to test the PHP code, but the ultimate goal is to get the swamp to the point where the swamp is running on itself constantly. And so we get to the point of doing our own dog food. Our security contact information, I just like to always put out there. And so just a couple closing remarks. I hope you come beat on this. The URL is continuousassurance.org, and we'd love for you to come test it, play with it, let us know what you think. And if you have any ideas on how we could be pushing this and making it better, I'm happy to hear it either in person or via email. So, and I do want to acknowledge and thank DHS for funding this. I think working on the software assurance like this is a really critical thing for the long-term security of the internet and all of us. And it's going to take a while to get it better. I think as a number of other talks I've seen here today, it's going to take some effort. I want to throw in a real quick plug. I think most of you got a flyer in your hands out, but CACR is hosting a cybersecurity summit actually this Thursday just down the street. And it's going to be a little bit different than here. It's going to be more policy level issues about cybersecurity. And we've got some speakers from DHS, ACLU, Cisco, and Indianapolis and state government showing up. And that's usually some interesting discussions and good debates going on there. And it's free. So if you happen to be here local on Thursday, please visit, register, and come on over. Any questions? Otherwise, I'll give you a real quick 2-minute tour. Yeah. Yeah, and thank you for the question. It's one thing I want to mention. We are going to be releasing it as open source. That is on our roadmap, and we're getting things there. I think not unusual. We had a really big push to get things working and out the door, and now we're sort of cleaning it up and get there. But our ultimate goal for those who really want to limit their trust is to release this as open source and let you run your own version of the swamp. Right. Right. Yeah, so you can do the IDE integration. So the first version of the IDE integration will just allow you to push a software package to the swamp and initiate the test and then get it back. And it'll be an automated process. It'll be a little bit slow. So it's a little bit slower than, if you're used to running something like lint or something right now, and you can integrate that with an editor, so it's, you get real-time feedback in your IDE. Ultimately, we would like to get to that point. There's some real sort of serious applied research challenges in that, because it can be hard to tell from just one, unlike something running like lint, which can tell you, oh, you've got bad indentation here. There's a question, how much source code do you have to push to the swamp? How much do you have to analyze to really tell whether or not there's a vulnerability in this? Because it may depend upon a function you're calling and whatnot. So we want to get that to real-time integration with an IDE. I think today it'll be more like if you think about commit integration, with something like Jenkins or something like that. So every time you commit, you can have something get pushed to it, and then you get feedback, in 10 minutes or something. Hey, your last commit introduced a weakness. Please deal with that. The sort of thing I think I've seen going on, Twitter has a nice piece on their software assurance program. That's the sort of thing they do, is the developer gets feedback in minutes time instead of immediately. Yeah. Right. You're talking about the Twitter Ruby on Rails test, or the name's escaping me, but pardon? Breakman, yeah. So, that's a very good question. I don't have a good answer for you right now. We're juggling features right now and working on that roadmap. So, sorry, I don't know, but once we do figure that out, we'll put it up on the website. Yeah.
What's your strategy for enterprises creating proprietary software and how they would produce the process? I know it would be a hard sell for us as they're currently doing it. Granted, what he said there would envision a lot if it was something that we could download and run on the servers.
Right. I think that, for the truly concerned, that course one option. Now, of course, that's fairly heavyweight, even though it's open source, downloading and installing it, it's kind of like free, like in a puppy. I would be interested in talking to you and understanding, and we're talking about legal and policy protections here. What legal and policy protections would we have to give you to make you comfortable uploading your source code to us, running it? We've said, look, we're not claiming any of your IP. We're not going to take your code and do anything with it. What is it? How do we codify that? What's the legal language that makes your lawyer management chain happy? And I'm open to input on that. My experience is, every company has slightly different ones, and we want to figure it out. So, if you've got feedback on that, I'd love to hear it. So, I'll turn the question around. It's really the best. Okay. So we've got 4 minutes at the top of the hour. I'm going to make sure you get out of here by noon. If you need to run now, you're not going to offend me. So this is a piece of source code you get when you ask a manager to write a piece of C code. For those of you who aren't using software development, this has got a really horrible problem in it there on line 9, where I'm copying from an argument that the user passes into a buffer that's only 10 long, and I'm not checking length, right? This is sort of bad programming error 101. And so just so you get an understanding here of what's going on, and let me give the quick tour here now, if my browser will respond. That's not the browser I want. Oh, there we go. So let's see, can we make you the right size? Okay, that's pretty good. And so this is my view into the swamp, and I've uploaded hack-me here, so this is my hack-me package. I've got a couple different versions of it. I had to debug my 5-line program here and get it uploaded. And then if I go up here, I'm a member of a project, and in this project I can define assessments. And so we've got different assessments here. We've got an assessment set up for Apache HTTP. Got a couple different assessments here. I've got 3 different assessments for hack-me set up for 3 different tools. And so what I can do here is I'm going to select one of these assessments, and I'm just going to ask it to go ahead and run. And my assessment run has been started. And so now we're sitting here, and it's been scheduled. And now I'm going to pull the usual cooking show trick on you. And we're going to go down here, and here's one I finished earlier. And I go to the results viewer, and up pops this page. And conference, web loading, internet speed, sitting here, blue beach ball of death. And you can see here, really simple. In this case, the CPP check says, hey, on line 9, you've got a powerful. Okay, so, cherry-picked example, obviously, but this gives you an idea of what we're talking about here in terms of functionality. And so we've got one warning here, clearly marked as a strong error, but you can sort of see if you were starting a development from scratch, this is the sort of thing give you good immediate feedback. So, and I'll stop there with the tour. The rest of it, is the usual web app progress bars, and you can imagine it. So, any other questions? Okay, well, thank you very much, and enjoy your lunch.